Last year you did a lot with graphing lines, and this year we're going to focus on graphing linear functions. So I want you to be able to identify linear and nonlinear functions. I also want you to be able to graph a line given the slope and a point, and graph a line given the x and the y intercepts. So let's start out with some vocabulary. And a linear function is a set of ordered pairs in which every x, or the input, is paired with exactly one output, which is y, with a constant rate of change. Now, linear functions can be written in the form f of x equals mx plus b, where x is the independent variable and m and b are constants. And I just need you to make that change right there. That should read b. Okay. You should know that slope is the change in y over the change in x, or you might say the rise over the run. Now, the y-intercept is the y-coordinate of the point where the graph intersects the y-axis, where x equals 0. So let's just draw a quick picture here of a graph. And if I want to know, if I draw a graph of a line like this, the y-intercept, this is the y-intercept, this is the x-intercept. Put a y in there, this is the x-intercept. Okay, so when we go down to the next line here, the x-intercept is the x-coordinate of the point where the graph intersects the x-axis and where y equals 0. Okay, to tell if we have a linear function, if you have a table, all you do is you subtract from right to left. So this is opposite of what you read, but I found that students make less mistakes if they subtract from right to left with the negative signs. So I do 25 minus 18, and that's going to give me 7. And then I do 18 minus 11, and that's 7. 11 minus 4 is 7. Okay, now, because we have a constant rate of change, if the differences between these numbers are not the same, then we don't have a linear function. So if I had said, okay, it's 7 here, but it's 6 here, I can stop. Now that we've checked the difference between the x's, we also have to check the difference between the y's. So we want to take negative 33 and subtract. Now be careful, this is a negative 24. So that's going to give us a negative 9. Then we're going to do the next one. We're going to take negative 24 and subtract a negative 15. And that's also going to give us a negative 9. So we keep going. Negative 15 minus a negative 6 is also going to give us negative 9. So the change in the x's is constant. The change in the y's is constant. So let's say the change in the y is going to be negative 9. Change in the x is 7. And it is constant, yes. So these numbers all have to match. These numbers all have to match, but these two don't have to be the same. So if all of the differences between the x's are the same, differences between the y's are the same, then we have a linear function. Yes, because it has a constant rate of change. The slope stays the same. All right, now we're going to do the next one. We'll do 4 minus 6, and that's going to give us a negative 2. And we'll do 6 minus 8, and that's going to give us a negative 2. And then 8 minus 10 is also going to give us a negative 2. All right, so the change in the x's are constant. Now we're going to go ahead and do the y's. We'll do negative 7. Again, I'm doing from right to left so I don't mess up my sign. So negative 7 minus 1 is negative 8. 1 minus 5 is negative 4. Okay, so right there, the numbers don't match. So it's not constant. So as soon as I get one that doesn't match, I can say that it's not constant. So no, the change in y, we can't find a constant. Change in x is constant, so that's negative 2. But the y isn't constant. So this is not a linear function. All right, if you flip to the next page, we're going to graph a couple of things. One thing that you'll need to do is if you're given a slope and a point, you need to graph the line. So the slope goes through 3, 1, so we'll go to 1, 2, 3, 1. The slope, remember it's rise over run, and the slope is positive. So slopes that are positive go up from left to right. Slopes that are negative go down from left to right. So from here, we're going to go up 1, 2, 3, 4, and over 1, 2, 3. And then I can also go 1, 2, 3, 4, and over 1, 2, 3. Now, it really only takes 2 points to make a line, but the more points you have, the better line you'll get. Okay, so that's graphing with a point and a slope. Now we're going to graph using the x and the y intercepts. Now remember, we said that when you have an intercept, if you're looking for x, y is 0. If you're looking for the y-intercept, x is 0. So basically what you can do, if we know y is 0, we can just cover that up. And now I have 6x. So I'm looking for the x-intercept. I have 6x equals 12. So x is going to equal 2. So that means my ordered pair is going to be 2, 0. So the x-intercept, y equals 0. That's what it means. If I'm looking for the y-intercept, x equals 0. So basically this goes away. I can cover this up. And I have negative 2y equals 12. So I can divide by negative 2. And I have y equals negative 6. So my ordered pair would be, we said x is 0. Y is negative 6. Okay, now I have 2 points to graph my line. I can say 2, 0, and 0. See, this is 1, 2, 3, 4, 5, 6. Negative 6. And then you can graph your line. Okay, you have a problem below. To try it for the you try it.